Morning class, and welcome to the second part of this unit. Remember, we're tying in Unit 7 and Unit 8 in together. So we just finished a quick unit on sequences and series, and remember, those are what's called discrete functions. This ties in as well the financial section is because it's also discrete functions. So that's why we're doing a combined Unit 7 and 8 test, because they both deal with what's called discrete functions, whereas the majority of the other ones, as you remember when we drew them, like sinusoidals, exponential, quadratics, those were all what we call continuous functions. Okay, so anywhere along any point along that graph would satisfy. And remember, we were drawing solid lines. So when we're taking a look at discrete functions, we're drawing just dots, and we don't connect the dots to create a function or a straight line. Okay, I apologize. They are functions, but they are discrete, so we use dots as opposed to a solid line to show that pathway. So that's why that's why Unit 7s and 8s are tying in. Now, ladies and gentlemen, I saved this part for the end of the course because I think it's probably one of the most important parts of grade 11 in terms of the mathematics. This is what we're going to deal with is real-life math. Okay, so today we're going to be taking a look at one type of interest. There are two types, simple and compound. Just remember, folks, that sometime in your life, you are probably going to need to borrow money or invest money. If you borrow money, so say you're planning to go to college or university, you need to borrow money from the government, called OSAP. A portion of it may be forgiven or you may not have to pay back, but there's going to be a significant portion you're going to have to pay back. So say you borrow $10,000. Maybe they'll give you forgiveness of $2,000, so you're still going to have to pay $8,000 back. But the government isn't just going to want the $8,000. They're going to want interest in the time it takes you to pay back. So you're going to have to pay back more than what you borrowed. Okay, and that's true when you buy a house, when you buy a house, you need to have a mortgage, or when you get a car loan. Any types of loans, you're going to have to pay back in interest as well as the amount you borrowed. Okay? The reverse we could talk about is investments. Hopefully you guys are going to want to start as soon as you can, folks, working on some retirement savings plans, which are called RRSPs. So say I put in $1,000 every year into a bank account. I just don't want $1,000 every year. I want $1,000 plus the interest that's earned on that investment. Okay? So interest can be a good thing if you are investing, but it can also be a hindrance if you are borrowing. And that's just a fact of life. So we're going to deal with two types of interest. One is called simple. That's what we're dealing with today. And next day we'll take a look at compound. Compound interest, or the next lesson, is more in real life when you talk about banking situations. Simple interest is worth mentioning simply because, say you borrow money from your parents. Or borrow money from a company. So say your parents have a farm and you're going to borrow money from the farm to go to school. They may do what's called a simple interest. When you borrow money from friends, quite often it's a simple interest exchange. So let's just take a look at the difference between simple and compound. Well, we'll just examine simple today. So just remember, guys, when investing money or borrowing money, the following common terms are used. So principal, capital P, is the sum of money that you borrow at the beginning. So that is your initial amount. Another word they call that, or beginning amount. Okay? I, interest. Interest is the money earned on an investment or the cost of borrowing. So that's the difference in how much you borrow versus how much you're going to pay back, or how much you invest versus how much you get on your return. Okay? And A is a new letter, and that's the total value of the investment, and that's the ending value. Okay? So that's at the end. Okay? So I want you to know this formula means the amount you borrow equals the principal plus the interest accrued on that, or the amount earned in your RSP is the principal plus the interest added on. Okay? Now here's the difference in terms of the two different types of interest. Simple interest is interest paid only on the principal. We will learn next day that compound interest is compound interest based on the principal plus the interest that's being earned or accrued, or accumulated is another word we call for that, but we'll save that for next day. Okay, but for simple interest, it's interest paid on only the principal. So let's take a look at a simple investment problem here. So example 1, suppose you invest $1,500 at 4% simple interest. What is the amount in 5 years? So remember, we're going to use a simple formula, which we're going to go down here. Simple interest has a formula I equals PRT. It's just down below here, folks. So we're going to put it in a box in a minute. Okay. At year 0, we haven't had any interest in it, but the amount we start at year 0 is 1,500. So now we're going to put that in, and what I want you to think about is each year, if you've got 1,500 and you times it by the interest rate, so change the percent to a decimal, so 0.04. If you plug that in your calculator, folks, you're going to get $60. Because it is simple interest, we're going to add $60 every time. And we're going to do what's called a running total. You may have seen this if you're familiar with doing spreadsheets, if you've done computer programming or anything. So you started off in year 0 with 1,500. If we add 60 to it, we're going to end up at the end of first year, we're going to have 1,560. And we don't need the dollar signs there, but you can put them in even though they're included. Okay, so at the end of year 1, we have 1,560. Year 2, we add $60 more on, so we have 1,620. Again, you plug in your calculator and you just keep adding 60, okay? And then the next year, you have 1,680. Okay, next year you've got 1,740. And the next year you have 1,800. Okay, so if we go to graph that, ladies and gentlemen, year 0 is 1,500. Year 1 is 1,560. Year 2 is 1,620. Year 3 is 1,680. Year 5 is, sorry, where am I here? Year 4 is 1,740. And year 5 is 1,800. Okay, and notice, ladies and gentlemen, that these are distinct points. We cannot calculate the interest at a year and a half because the interest is for the entire year. So that's why when you deal with investments, you're going to have to lock them in for a solid amount of years. Okay, so it may give you, say, 4% for 5 years. Okay. All right. So notice here, ladies and gentlemen, that we keep the dots like this. If you want, you can do what's called a dotted line, a dashed line, okay, to show your trend. If you wanted to say, hey, how much am I going to have in 7 years or in 9 years? So, for example, look at this trend in 9 years. You should have around $2,000. Okay, but we do not join the dots because it is a discrete function. So let's just write that down. Keep it a dotted line because it is a discrete function. And I wanted to relate this, ladies and gentlemen, to either a sequence or a series. Okay? So first of all, if we take a look at individually these numbers, okay, it is what we call, if we don't total them, but we just look at the increase in the amount, okay, you're going to realize that this is what we call an arithmetic sequence. So that's why it ties in to the last unit as well. All right, so we've got, it's a discrete function, so we don't join the dots. And it's an arithmetic sequence because if you take a look, ladies and gentlemen, and do the change in the amount, or delta A, just like first difference is, guys, the change each time is what? $60. So just think if I had those numbers in a line, just like we did last unit. Okay, you know A is 1,500. The difference in each case is going to be 60. Okay, all right. So that's why we call it an arithmetic sequence. All right, let's go on to the simple interest formula. Okay, so the simple interest formula is I equals PRT. Sometimes you'll see it with lowercase letters, sometimes you see it with capital letters, depending on how your publisher prints their textbooks. Okay, just remember that the rate is per annum. That's a new word meaning per year. Okay, so if ever they say, hey, what's the investment for 18 months, you're going to have to relate that to 1.5 years. Okay, because time is in years and rate is per year. Okay. One thing to remember, you may have seen this in physics, guys. We want to be able to rearrange this formula. So say we want to find the principal if everything else is given. We use which is called the pyramid. And you may have seen this in science, folks, so I'll just explain this. So I equals P, R, and T. So it says here down below, right here, we can rearrange this formula to solve for the above variable. Okay, so if we want to rearrange it to solve for R, take your fingers, guys, cover up R. So, for example, cover that up, and what's left over? So R equals I divided by P times T. And just remember, P times T needs to be in brackets, okay, or PT. All right. Uh-oh, now I need to erase that for a second so I don't cover up R. Sorry, guys, give me a second. Yeah. Okay, so hopefully you get the hang of that, guys. And just remember, guys, this is what we call the divide line. Okay, so let's fix that back up. I divided by PT. Okay. If I cover up P, ladies and gentlemen, what's left over? I divided by RT. Okay. And if I cover up T, I've got I divided by PR. All right. Now, ladies and gentlemen, interesting to note that this formula is I equals PRT, and the one above here, right here, has an I in it. So I can substitute the I part for that and put it in here if you're asked for a question and the interest isn't given. So we can also combine it with the interest formula above. This is used when you're asked for the total amount and the interest amount is not given. Okay, so let's use this example for the above. Okay, so first of all, what do we know? So in financial math, when we're doing math questions, we're going to write down our givens and what we're looking for. So we want to find the total amount from that word problem we just did. We know our principal, ladies and gentlemen, was $1,500. That's how much we started for our investment. Our rate equals 4%, change it to a decimal, 0.04, and we know our time equals 5 years. So using that formula, I'll just rewrite it out, but you've got it right there. So sub in what we know. Principal is 500 plus the principal, which is 500 times the rate, 0.04. I got to multiply that by 5, which is really your interest amount, guys. Okay, plug it in your calculator and you should have $1,800. So therefore, $1,800 will be in the investment after 5 years. So ladies and gentlemen, let's just go check. So go up here to our chart, and after 5 years, hey, how much is in our account? $1,800. So we don't have to every time write that chart out. We can use the formulas and get that all in one step. Just keep in mind, guys, for all financial math, you need to show your givens, which would be 1 mark, indicate which formula, show a substitution, an answer, and a therefore. So we're looking at generally 5 marks for any of these types of questions, okay? Okay? Keep that in mind, please. All right, let's do a couple more examples, maybe 3 more, and then we will be done. So example 2 says here to calculate the interest earned on a total amount and the total amount, so there's 2 different questions there, of the investment. So for A, it says we got $10,000 at 4.7% for 12 years. So first of all, what are we looking for? We need to find the interest Step 1. Okay. We also need to find the total amount. That's going to be another question. Okay. What information is given to us? 10,000. So principal equals 10,000. Okay. Our rate is 4.7. Change it to a decimal, 0.047. Okay. Even though there's a decimal in it, guys, it still has percent, so you still have to divide it by 100. And lastly, if I can change colors here to keep it working, t equals 12 for 12 years. Remember, time is in years. So for step 1, to answer the first question, I'll do that in blue. Interest equals PRT. Show me your formula you're going to use. Sub your information in. So we've got 10,000. Forgot my dollar sign on there. Let me throw that in. Times 0.047 times 12. Okay, sorry, I'm writing on an angle there. Okay, and plug in your calculator. Should get $5,640. Okay, at the same time, before you do the reverse statement, I'm going to do the second question, which is A. So A equals P plus I, because that's the interest amount. So the principal is 10,000. Plus your interest amount, which is 5,640. Total those together, 15,640. And then you can do one combined therefore statement, but make sure you have it. So therefore, $5,640 in interest was earned with a total investment of $15,640. Okay? Cool. Let's take a look at the second example. I'm not going to color code it this time. I'm going to go a little faster. Okay. So we need to find, in this case, I and P. Sorry, I and A, my fault, ladies and gentlemen. Okay, principal's given at $2,500. Okay, rate, change it to a decimal, 0.12. And be careful here, time equals 5 months. Well, how many months are in a year? 5 over 12. Just leave it as a fraction. Let the calculator do the work for you. Okay, so I equals PRT. I equals 2,500 times 0.12 times 5 divided by 12. Plug in your calculator. Ladies and gentlemen, I usually start here with a fraction and go 5 divided by 12 equals, and then go times 0.12 times that. Then your fraction's out of the way. And plugging in your calculator, you should get $125. Okay. Subbing in the second part, A equals P plus I. So the principal is 2,500 plus 125. So that equals 2,625. And then do your therefore statement. So therefore, sorry, that's on a diagonal. Let me fix that. So therefore, $125 in interest will give a total value of 2,625. Okay, last question. How much do you need to invest at 7.5% interest? So the rate's given. Change it to a decimal, 0.075. To have, careful here, to have, that's your end amount, so that's A. To have $5,000 at the end, and our time commitment is 8 years. So what we're trying to find is how much do we need to invest now? Okay, that's actually your principal. So we're trying to use your principal. Okay. So we could switch that interest formula, the simple interest formula around, but guess what? We don't have I. So we don't have the interest amount, right? So therefore, we're going to use the combined formula, which is A equals P plus PRT. Sub in what we know and try to rearrange it. Okay? So what we have, the final amount is $5,000 equals our principal, which we're trying to find, plus our principal times 0.075 times 8. Collect like terms, sorry, or before you collect like terms, let's simplify first. So you've got P or 1P, right? Plus, use your calculator, 0.6P. So just multiply the 8 times the 0.075 times the P. Okay, now we can collect like terms, guys. So 5,000 equals 1.6P, because remember, guys, in order for P to exist, there's really a 1 in front of it. So when you add those two together, you've got that. Okay, to get P by itself, you divide both sides by 1.6. Okay, so P equals 3,125. So therefore, you will need to invest $3,125 now or at the beginning to have $5,000 in 5 years. This is an interesting scenario, guys. Most people don't think about this, but you're going to want to plan. So you're probably going to plan to have some money saved up for university. You're probably going to plan to have some money saved up for when you get a car. Especially, the biggest investment you're probably going to worry about is your save up money so that when you retire, you have enough money. My question for you is, how much do you think you will need as a retirement amount so that you can live your life when you retire? I'm going to leave that with you, and I want you to ponder that. Maybe have a discussion with your parents, because what your parents have now saved up for retirement is going to be much different than when you retire, because it's going to be several years later, and the value of the dollar is going to change. So I want you to think about that and have a little discussion in class about how much money you think you will need to have on your date of retirement. All right. Have a great day, folks. And as always, come and see if you need any help. Namaste.